Another question from the chapter Surface Area Volume, Mensuration, Class 8. It says two cylindrical cans have the same bases, right? The bases of the same size, and the diameter of each is 14 centimeter. Further, it says that if one can is 10 centimeter high and the other is 20 centimeter high, we have to find the ratio of their volume. So what we can do here is to make two right circular cylinder. Well, as usual, the diagram is not important, but it helps in visualizing. So if I make a cylinder, say one and the other cylinder being this, keeping in mind that they have their same bases, so their base is same in each case, while their heights are different, right? It's not up to the scale, but should be proportional. Now, what do we have here? The information is that their diameters, right? The diameters is 14. So that means the radius of each will be 7 centimeter. So both radius I'm using R to indicate it is 7 centimeter. Further, we know the height of the one can as 10 centimeters. The first one, the height of the first can, and this is the height of the second can. So we have their height given as, for the first, say if I use H1 is equal to 10 centimeter, and for the other, the height, say if I use H2, it is 20 centimeter. So we have to find the volume of ratio of their volume. Now, what I have observed that most of you actually solve it by actually calculating their values, the volumes of each, and then finding the ratio. But we should do the other way, like we should first find the ratio, right? Now I can replace V1 with a formula for the volume, calculating the volume of a cylinder, which is pi r square h. I'm using H1 here for the first, and similarly we can write pi r square H2. Now this way what happens that we can cancel this pi r square as the radii are their same, right? As you can see, the base radius is same, so we can reduce them as they have the same values. Now, in turn, we have to get the volume of these two cylinder, ratio of the volume. I can replace H1 with 10 and that of H2 with 20. It gets reduced by 1 by 2. So finally, we can say that the ratio of the volume of the two is V1 is to V2, that is 1 is to 2. This will be 1 is to 2. And therefore, that should be the answer for this particular question.